Okay, and a good morning to everyone. And that was Buddy Holly, and the cut that was just before we...
Peggy Sue.
Peggy Sue. Do you want me to move, or what do you want me to do to try to... Because I'm going to be over a little bit there. That's... Okay. Now, for those of you who are watching, we may have some focus problems, a little bit of herky-jerky as we try to get the camera to cooperate. So I'm going to minimize my movement this morning. And so if I'm not looking as clear as usual, you don't need to check your eyes. And we'll try to get by with what we can. So there's a lot of things we need to talk about this morning. And the first of those has to do with an exam we took yesterday. And it is graded. And so what I'm going to try to do is get some things out here while I'm at it. Could you pass that over to James? And Robert, I've got an exam for you momentarily. Here's yours. That is courtesy of Microsoft. That's not a cell phone. Okay, the computer just booted up. And have I got... Okay, I saw Chris going for the headphones, and I thought maybe I didn't have the microphone going. In terms of the test, my goal this morning is to go through the test, look at it problem by problem, see what should have been there. Overall, this is just to share as a group because I didn't have the opportunity to talk with you before we started. The grades were very good. 50% of the class A's and B's. That's awesome. 85% at C or better. So it went very well. Now, saying that, I know some people who are not pleased with the fact that they didn't do as well as they wanted. So the question, what can you do to do better? Okay, and so if you were to determine your grade right now, what you want to do is look at your quiz grades. You have 3 quiz grades, and balance that out with your homework average, and then balance that out with this test score. So you have 3 grades you could combine right now, because I will be combining 3 grades for your semester grade. So let's say that you're running 90% on your homework. So 90% on homework, and you had 80% on the test, and you had quiz grades at 70%. So you have a 70, 80, and 90. You'd add those 3 together and divide by 3. So that'll give you a better idea of how you're doing. Most of you on your homework grades will improve your test grade. I think just about everybody will improve their test grade with their homework grade. And most of you will find your quiz grade pretty close maybe to what your test grade was. Let me get another test out here. Erica, if you want to come up here to the side, you can pick up a test. That'll give you a chance to see what we've got going here. So the first problem, we're going to go there in a moment. The first problem is the one problem in the test that I apologize for because I wasn't thinking of a restriction that I was critical of the computerized homework of not considering. Namely, the answer came out a fraction and should have come out an integer. And James came up and asked about it, and I realized, bad choice on my part for what I did. So let's cut to that problem. As I say, this is, for me, a bit of an apology. Now, that's clearer than the camera shot was. It was a fraction, 3x minus 1 over 2 plus 5y. And again, I ask you to let x equal minus 1, y equals 2. So as we look at that and substitute, this is what you should have done, and you just end up with negative 4 over 12. That should have come out an integer, and that's where my apologies come in. Now, coming off that for a moment, some of you decided to reduce the fraction. Okay, I'm pleased with you. I mean, reduce fractions when you can and get negative 1 over 3. But for those of you who tried to divide negative 4 into 12 and not get a fraction, let's look at the fraction again. It is not an improper fraction. It's a proper fraction. So all you could do is reduce that. Now I ask another question. What value will make that denominator 0? So let me come back to the 5y plus 2. Now this was the problem, and I'm trying to remember who asked this problem. The very first problem we did in the front of the room, it was on the board and it had a V in it, and I can't remember who asked the problem, but it was whether we had an undefined or an indeterminate. It was Isaac. You've been blamed. Okay, remember it was the problem where we had a V in it. Now, okay, so what will make that denominator 0? Oh yes, not an integer. That was the bad part of my choice. If you multiply 5 times negative 2/5, think of that again. Okay, do I have any option on any cameras at this point, Chris? 2 is, okay, 2 is on the board behind me.
Yes.
Okay, let's try going to that. What I wanted was 2 plus 5y equal to 0. Yeah, I should have lowered it. You want me to? You're going to be able to bring it down? Okay. You could have said 5y is equal to minus 2, correct? Then what? Divide both sides by 5. And this is where I apologize because I'm getting what? Not an integer, I'm getting a fraction. And it should have been strictly an integer. But if it'll make you feel better, I don't think anybody got that right. Okay? Did you get it right? Okay. One person did. Good. Okay? But that was not my intent. My intent was about all of you being able to answer that question. But do you understand what you'll be asking? When will the denominator be 0? Solve for that. And the only bad thing is I should be getting an integer because I was in a chapter with integers. Now this was done to you in a computerized version. And what happened here, when I was writing this up at 4 a.m., it was the first problem I wrote, and clearly I had not had enough coffee yet because the rest of the problems worked well. So out of the gate, it didn't work as well as I wanted. Any questions on this problem? Dion?
I don't even know how you had the 5. I mean, you know how you divided them both, like by minus 5 at the bottom?
I wanted y by itself, so how can you get rid of a coefficient?
You divided by it.
Divide by the coefficient. And then what you do to the left side, do to the right side. Now, we have done problems like that in the homework where we had 3x equal to maybe 12. And then you said, divide both sides by 3, which is the same as just putting a 3 under here and a 3 under here and getting x equals 4. That same process. Now, what led me to do that? Well, if we look back at the document cam, I have a fraction in which the denominator is this expression. I cannot allow it to be 0. So again, that expression right above the red pen is what I have up here. So I asked the question, and I'm focusing on this because this is where we're headed very quickly. What restriction do you have to place on the variable? The variable is y. This expression cannot be 0. Okay, what makes it 0? Negative 2/5. Do not allow that, and we say we have a restrictive what? What's the word? I didn't put it on the test. The domain. The restricted set. We don't allow this because it made the 0. And obviously that did not go across well. Most of you sort of didn't get it. Back to the document cam. Okay, right below that was a polynomial, and it was 5x minus 3 plus 2x squared. And I really wasn't writing downhill. Come off that for a moment, Chris, if you could, so, and maybe to the other camera so I can be a little less than the head in the corner. There we go. And that, is that camera 1 now?
Yes.
Can we bring that in any tighter or not?
It'll get more out of focus.
No. Okay, well then I'll be a distant figure. That's good right there. Let's come back to the document cam. Here's my trinomial. Trying to give Chris plenty of practice of what buttons to push, what toggles to do. Okay, for the first solo bit, to have a malfunctioning system is challenging. Here we go, solo flights. I wanted it in descending powers of the variable. So to do it in descending, it should have been 2x squared plus 5x minus 3. So this gets brought over here. So as I do that and show you what it looks like, there's the solution. Question, Isaac?
No, I did it right?
Well, I'll look at anything you have for me to look at afterwards. Is there a general question? Because I can't leave up here and check what you're doing when we're going to try to go through the test and I've got to stay on camera. So I'll look at it after the fact, but it is a trinomial. That's what the polynomial was called. And it is second degree because this exponent was 2. Now, after all the frustration we had, I was delighted with that problem. I thought that was going to be a very... Boy, I'm having trouble watching me at that bad of focus. Okay.
Oh, man.
Yeah, you don't want to watch too closely. You go cross-eyed. Maybe go to camera 2 or something. Okay, that's much better. Now, questions on that as far as the degree of the polynomial. There were 3 terms to look at. Michael.
Were we supposed to switch the signs? The order of the signs?
Ah, good question. Yes, the signs have to go with the parts. So let's come back to it. Keep in mind, as we go back to the document cam now, that this, in its original form, what do? You trade off that for plus a negative 3. So again, that subtraction is plus a negative 3. Now, I have 3 things added. A negative 3, a 2x squared, and a 5x. So I can rearrange those and the sign stays with it. So as I look at that, let me try modifying it as we come off there for just a moment, Chris. Okay, what I'm going to do is make this plus a negative 3 above it and see if that helps with the idea. Let's cut back to it now. Does that help, Michael? Because now when I rearrange and I bring this 2x squared over here, you see that the minus 3 has to stay with it. So, and all I had to do is really move this one term here over to here and leave everything else as is. That's why I didn't worry too much about that minus sign. You've got a look that says that's not communicating. Do you want to discuss it further?
Well, no, just because maybe you made a mistake on my test.
I may have. Okay, I was grading, and as I say, if there are questions, I will address those afterwards. Well, for right now, as long as we're clear as to what needed to be done.
Yeah.
Okay,
yeah.
That's my only concern now. So, Dion.
I don't even, so you was only supposed to switch that part of the problem?
Well, you could have done it in different ways. Let's come back to it. Back to the document count. Because I had 2 choices here. One, I could just move the 2x squared over here. Or I could do what? Move the 5x over here, the plus negative 3 over here. But any way you do it, it's got to look like that.
Okay, so why did you, how did you determine what you using on?
Okay, what is not seen here that we talked about is the unseen one. And I ask you to do descending, going down, powers. So that's the second power, first power, and technically this is what here? X to the 0. We don't usually write the x to the 0, but now notice the exponents, the powers, go down in descending order, stepping down. Now that may not have been as clear as I thought by saying descending power, but it's something that was used in the text and in the computer homework with that same phrase. So what I tried to do was keep my language very consistent with what you were doing in the book. Okay, the next one. Now, I asked formula, substitution, and answer. Formula, substitution, and answer. This was about the voltage of an electric current, and I thought this was one of the nice formulas we had. V equals IR, and technically A would not be an appropriate, even though we call it in amps. The I is for the current, so I was a little bit of a stickler there. Pure substitution made this, and then you divided both sides by 44 to get your 5 ohms. Now I really wanted you to write ohms, and I wasn't asking you to meditate where you go coming off there, but I didn't get it from a lot of you, so I didn't take the points off. But technically the resistance is measured in ohms, and there's a nice little bio about the person involved with the name for the resistance. I don't know if you realized it. I'm going to come down. Just come off there for a moment, Chris. One of the things I tried to do here was to take the most recent material first. I thought if I did that, we'd been spending so much time talking about it, I worked backwards. So the things we had just talked about with degrees, the descending order, naming the polynomial, and that worked from the standpoint you really did well there. This one on voltage I thought was recent enough that you do well there, and mostly I had to take 2 points off because you didn't write the formula and then show me the intermediate steps. Some of you gave me the answer but didn't provide the steps I wanted. Okay, let's come down to this one, which is simplify, and we had absolute value. Okay, and the key here is divisions and multiplications first in order given. So that was a division of 21 divided by -7. That gave you the -3. You still had your -12. Now, getting back, Michael, to a question you had, I could have said -3 plus -12. That is a -15. The absolute value of that is 15, and you're there. Okay? So, pardon? That is number 4. Number 3 was the one on the voltage, IR, that we just talked about, and that was where you got the 5 ohms, and you were supposed to write the formula, and without 5 ohms, or just a 5. I just mentioned, and if I remember correctly, I'm talking to your paper, in which you did not write the formula. Is that correct?
Yeah.
And you didn't show me a substitution. Is that correct?
You saw how I got it.
I know, but is that correct? Yes, it is. And so I took 2 points off. Is that correct?
Yeah.
And I thought about taking 3. But I thought, nah, I should only go 2. Okay, continuing. The next problem is perhaps the most difficult in the test. So here's the first braces. Now, right below that, this is where some of you lost it. The -2 to the third is the -8. The 4 is outside those brackets. Now, inside these parentheses, you have a -2 with a negative sign outside it. That makes it a +2. 6 and 2 is 8. No, you look at what's up on the screen. Again, watch what is being done there. You have a 3 minus a 5 that I'm pointing to with the red pen. That is a -2. You're subtracting the -2. That makes 6 plus 2, which is 8. Now, you have 32 here. Minus 8 is 24 on the left side. Let's look at the right side now. This was 64 plus 6 squared. That's 100 inside. The square root of 100 is 10. 10 minus 2 is 8. So you get -24 over 8. Very few people got this all the way through, and the answer is 3. Okay, now I'm not going to try to isolate on everybody's. This problem, some of you went through 5, 6 lines, and it would mean taking time to go through each line, and that's where I hope you will spend time with Larita on that, making sure you understand where you had your problem. She will be delighted to go through about 500 lines of work. It was not fun, I'll tell you, even with coffee. Okay, coming to the next problem. This was a two-parter to double your pleasure. Okay, this is number 6A. -1 times -3 times -5. You had three negatives multiplied together, -15. I had hoped that was a fairly easy problem. And then over here, I did a quotient of -75 divided by -5 and got 15. The next, and those are 3 points off. Each problem was worth 5, but if you missed a part of that, I took off 3 for each part. Here's an interesting one. This is where some of you got trapped, right here. Most of you got trapped here. I did not have a parenthesis around the -3.
You didn't?
I'm showing you what's on the screen.
7?
This is 7B. There is no parentheses around the -3. Check your test. I'm taking a copy of the test. So the 2 only is attached to the 3. So that means you have the additive inverse of 3 squared, which is -9. This, where you had a -3 to the third, means -3 times -3 times -3, and that is -27. And most of you got that right. Most of you got this wrong. And if you missed the sign here, I'm sorry, no partial credit on this one. Yes?
I don't get it. I thought two negatives makes a positive.
Yeah.
The product of two negatives is a positive. The question was, I thought two negatives made a positive. You have to be careful that you say that better. The product of two negatives is a positive. This 2 does not influence this negative sign. It is only attached to the 3. The only way you bring that negative in is like I did here. That's what you were supposed to pick up in the examples in the text and the work on the computer. And that's all I can basically say about it now. No parentheses. The 2 only involves this 3 giving you a 9, and hence it's the additive inverse of that. Coming off there, Chris, for a moment. I ask you to write the following as an addition. Before we go there, Chris, I need to write in something for myself as far as showing what's done here. This is the step that should have been done, and I'm not convinced that I perhaps did it grade-wise in terms of grading it as well as I should. I may have let you slip by something here that I should have been more critical of, but here's the problem. The problem was a -15 minus a -13. Here's rewriting it as an addition, and I just recall at 5 a.m. this morning that I probably did not check for that step and should have. So if you didn't do this step and got by with it, you managed to get by with 2 points. Enjoy your gift.
Thank you.
Now that becomes -15 plus 13, which is -2. And I was just looking for the -2 and didn't focus on the fact this line should have been there. So on another test, such as the final, if I had a question like this, I would expect to see the line I am pointing to with the red pen. Any question there? James? Okay? Your eyes don't agree with what you said, never mind. What I've got right above the pen is exactly what was on the test. -15 plus 13 going from here to here. Okay.
It just comes to you in your head.
I know, but okay, coming off there, Chris. I've got ambivalent feelings about your question. What James is asking is, could I omit going from where I'm pointing to now as we come back to here where I treated that as a plus and then a minus 13. I know that creates this, but let me say now my expectation in a future problem would be to go those 2 lines extra. Because I do want you to understand that this means add the negative inverse of whatever's here. That then is at least the interpretation for the addition. The next step is to realize the inverse of an inverse of 13 is just 13. So in the future, since the question's raised, I would expect the additional step for full credit. The next one, this is an equation. I ask you to solve, and what most of you did is similar to what I did there. That is, you added 13 to both sides and got 38. And then when you check that, you're supposed to do what? Place the 38, I'll come off there just a moment while I write in a check line. I looked for this, but I, at the same time, didn't write it here. Okay, now let's look. This is where you would check. You would substitute the 38 for x. You would add in a negative 13, and I should have put the negative, I put that parentheses in the wrong place, so let me correct that off there for a moment, Chris. I should have done this, get rid of that, and put the 1 there, and I hope that reads better. Let's try it. That little worm there is not part of the problem. Okay, but I don't have anything I can put on the paper to modify that. But is there any question there? Again, you should get 38 because we added 13 to both sides. I wanted to get rid of this negative 13. So I added 13 to the left side, and that became x plus 0. That became x. On the right side, your 25 plus the 13 became the 38. Okay, coming off that. The next was just an addition problem. I needed something that would be from an earlier section of the book, so let's go to the document cam. I can only do part of it at a time. We had negative 25 plus a negative 10 plus a 5 plus a 20 plus a negative 12. So what I did was what I encouraged you to do. I combined the negatives and the positives together and then got my negative 22. Now you could have done it. Let's come back. Let's try again. Okay, some of you did this for me. You said negative 25 and negative 10 is negative 35. And then you said plus 5, and you should have had negative 30. But some of you said 40, and then it was downhill from there. Okay, because the negative 35 and the plus 5 would give you negative 30, not a 40. Enough said. Okay? Yeah, so you saw it as negative 35 plus 5 plus 8. So what is being said there is seeing this, leave that as a 5, and then come over here and see this as a plus 8. Yeah, that'll work. Generally speaking, I think you're going to find one of two ways of doing that, combining the negatives first, then the positives, or step by step as you go across, one part at a time. I saw a hand go up. James? Okay, what method did you use? Okay, coming back, that'll work also. I concur. Negative 35 here, then plus a 25, and then a minus 12, or plus negative 12. Yes. Yeah. Different ways. What defends all that? What property coming off there? The associative property of addition and the community property combined would allow us to just rearrange that any way we want, called mix and match. But if you got a 40 in those first three terms, all the mixing and matching will not take care of the error. Okay, page 2. In terms of time on the test, I was very comfortable with that. A few of you got done early, but a few of you who got done early did not spend the time you might have spent on the properties. So you could have used that time, I guess, to an advantage. And then a couple of you at the end needed a little bit more time to finish. And I felt the balance was pretty darn good. Wasn't that unhappy with it. I didn't have 20 people waiting to turn in the test at the end because they didn't have time. And that's a good way of measuring it for me. Okay, we're adding again. This was one in which I don't think I had a malice intended, but I had a negative, and a negative, and I was adding them together. I regret I didn't have a fourth negative. Why? What was your trap, if you aren't careful, coming off that, Chris?
Because you would think that they just cancel each other out.
Yeah, because you have 4 negatives, you'd think, like in multiplication, you would get a positive. And if you were thinking multiplication rule here, 3 negatives make a negative in multiplication, even though it was addition, you were thinking badly, and I didn't catch you thinking badly. So I apologize. I should have had a fourth part here just to make sure you were doing it in the proper mindset. Coming back to the problem, again, I don't know which makes more sense, but I hope you saw this as a negative 10 immediately with a negative 5 for negative 15. That problem I apologize for because it wasn't probably hard enough. This problem is one that we did in the tutorial. A negative, the absolute value of negative 5 versus a negative of a negative 5, and I think this was Sochi's question. Making the distinction between a parenthesis and an absolute value. So here we have to do the absolute value first, which is just a 5. And then I'm asked to take the inverse of that 5, which is negative 5. Here you can treat this like negative 1 times negative 5, which will give you 5. That's one way of viewing it. Is there any discussion there as we come off of it? That problem went rather well. I was impressed there. And so I remember where that problem was on the board. In fact, when we had to redo the lecture at 3 o'clock in the afternoon, we came back to that problem at the very end. I believe that was the last problem we looked at as we redid that. And I got to see part of that yesterday as I was watching the television of the broadcast that we did. This next one came from a question we did in the board. A minus parentheses. It looks like brown faces, unhappy faces in a row. So all you had to do was what? Count the number of negatives, and it was 1, 2, 3, 4, 5 of them. So that made it a negative at the end of negative 3, and that went beautifully. Some of you said negative 1 times negative 1 times negative 1 times negative 1 times negative 3, and you got the same answer. The key was the number of open parentheses matching the number of what? Closed parentheses. Sliding over. This was to, again, attack that idea, the difference between parentheses and absolute value. You didn't need to know how many of these were in here, because the absolute value has to be what? Positive. But if you wanted to play the game according to rules, the absolute value of that is, okay, let's come off there for a moment. I can't pass this one up. It is the additive inverse, and I'm going to put a brace there, of, okay, I've got to make sure I've got enough minuses here. Okay, now, as soon as I find where that is on my page, okay, Chris, we can go to there. Those are pretty sad-looking braces. But this is the additive inverse, and inside the brace is what I had inside here. So the additive inverse of the additive inverse of the additive inverse of the additive inverse of 3 is 3. This was a negative value, so its absolute value is the opposite of the value. I like that problem. Okay. I told you as we come off there that I would haunt you with a previous quiz problem or two. Here it is.
Yeah.
And the frustration was, you didn't get it. Some did, but not as a group. You had to add the 3 inches to the 6 inches to get 9 inches. You must write the formula, show your substitution, and get your answer, and square inches. Okay? That was disappointing when I mentioned to you that you'd probably see that again. We did that in a quiz. Yes, deja vu. Coming off there. I tried to simplify this one for you. You didn't seem to appreciate it any more than the PBS one I did on the board. Coming back to the document cam. This is a right triangle. Now, I didn't tell you the 3 in the original problem. You had to pick up that in one of 2 ways. You could have remembered the Pythagorean relationship. 3 squared plus 4 squared is 5 squared, and you knew that had to be a 3. Or you could say this is 8 up here, this is 11 down here, so that has to be a 3 here. That would have done it, right? And so what you then had to do is understand you had a right triangle, a rectangle, and a half circle, right? So we had to find the area of 3 things. Take that back to Richie, please. And so what I have over here in various places, here's the triangle, because this was a 3, 4, 5, and remember you don't use the 5. It was 1/2, 4 times 3, which was 6 square inches. On the area of the rectangle, 4 by 8, 32 square inches. And then it's a half circle with a radius of 2, so it's pi times 2 over 2, which comes out 6.28 for 44.28 square inches. Folks, welcome to Math 10. Straight out of a Math 10 problem. Okay? It's a good one to review.
I got it. That was 5 times 2.
Now, if you have something I didn't catch afterwards, I can't respond. If it's a general question, I'll be happy to answer it. Which is it, Michael?
Well, I know I made a mistake here, but I got the right answer, and I don't know.
Okay, if you made a mistake and you still lucked out, I still took points off. So if you did something in error but managed still to come up with the right answer,
Yeah.
I still would take a point or 2 off because it was based on an incorrect defense.
I'm just curious how I got the right answer.
Oh, I realize that. I'll be happy to talk about that, or Larita will, but I can't do that at the moment.
All right.
Okay, continuing. This one, now remember we're working backwards in the text. So this is where you first had radicals, square roots. So you had a 3 times the square root of 25, you had a minus 20, you had a divide, you had a 4, you had a times 3, you had a plus 7. Order of operations. Radicals first. Hence 3 times 5. Then I just simply rewrote it. Now, your 3 times 5 is 15, minus what? 5, because you do the division next. So you have a 15, and then you have a negative 5 times what? A 3, which is 15. So you have a 15 minus 15, that went to 0, plus 7 is 7. This is a number added to its additive inverse, which gives you the identity, which added to 7 gives 7. That went very well. Any question in that one? Okay, coming off that for a moment. Chris, question? Soshi?
Yeah. I left it, instead of putting a parentheses, I left it as a square root after I got 5.
Okay, so we come back to here, okay?
Yeah,
You left the square root on there?
Yeah.
With the 5?
Yeah.
After you take the square root, you want to get rid of that symbol, because if I left the square root in there, it says take the square root of that, which happens to be 2.236. So if you had a square root over that 5, I would have to replace that with a decimal.
Okay.
So once you've taken the square root, throw away the radical.
Okay.
Any other questions there coming off for a moment? Okay. Now this part, most of you got the square root of 169, as we go back, was 13. This is where some of you didn't remember a very important point. The square root of a product is the product of the square roots. So you could have said the square root of 225, which is 15, the square root of 400, which is 20, and get 300 and be done. Now some of you multiplied 225 times 400 and got 90,000, which is 300 times 300. I don't mind you working too hard, but remember, this is the square root of a times b is the square root of a times the square root of b, and it makes it much easier. While we're at it, this was exponential form. That's all I wanted there, Soshi, was 5 to the 6th. Okay, that's what it meant by exponential form, and I felt badly because that, if you did anything else, it was much easier, and It means there has to be an exponent when you say exponential form. Okay. Okay, question off there? Coming.
He actually confused me because I know the answer was 300, and I got 300
What?
right there.
Wait a minute.
5 times 20, 300.
Where are you getting the 5 times 20 on this problem?
15 times 20, sorry.
Okay, just a minute. This is my problem.
No, we're going back to 17B.
Oh, we're going back to here?
Yes.
Oh, we aren't done there. Okay, now what's your question here, Robert?
I knew that the answer was 300 because I
Yeah, okay, 300.
But I don't know, it confused me because when you asked him for the square root, I thought you were looking for an actual small number.
It is small.
300?
300 is a small number compared to 90,000.
That's why I asked you if it was supposed to be if it was supposed to be a decimal or something, because I was actually trying to break down the 300.
But hold it, the 300 was what you get after taking the square root.
I got that answer.
Okay, you're talking about the same kind of problem Sochi had, still thinking there's a square root over the 300. The 300 is your answer, no longer a square root taken.
Yeah, I didn't get it.
Okay, coming off there. Okay, yeah, you have to be careful. Okay, things are getting progressively easier. That was the intent. As you're getting progressively tired, things are getting progressively easier. So I gave you this one, 7, 314, 159. By the way, you want to know where those digits came from? That's pi, 3.14159, without a decimal, and throw a 7 in front of it just because. So that's what my head was thinking when I wrote the problem. Now, I felt very badly for those of you who forgot that the last, and I screwed up something there I see immediately. That should have been 10 to the 0. But as you look at that, the 9 here at the end is 9 ones. So that starts at the 0 power, then goes to the first power, second power, and ends up at the 6th power. Some of you started with the first power and went to the 7th power, and I hit you pretty hard. That was a Math 10 problem. Okay. This one I was pleased with because this caused a lot of angst, concern on the computer, and I think I only saw one mistake in this. You're supposed to round off first, and you round off the smallest number to a single non-zero digit. So that had to be a 7 here, then 0, 0. Then everything else has to be rounded off the same way. And most of you did that, getting 15,300. You added here, got your 15,325. You ended on a very positive note. Okay, coming off there. Then there was another page, page 3. I feel like Paul Harvey. And now going to page 3. Now, the nice thing about the extra credit problem, I didn't have to curve the test. So here's the problem. A, B, and C belong to big R. That's not the store. That is the real number system. Now, I wanted you to give me 10 properties. I know there are 11. I just wanted you to give me 10 that we've covered up to this point. So, as we come off there, we will now take time to reconstruct those. Tabitha. These are what I want you to know, okay? And some of you had a chance to repeat a quiz by doing these and didn't take the opportunity. So let me write down first a property, and I'm going to ask you to tell me what these two are called, okay? The closure property, A times B belongs to R, A plus B belongs to R. So we had here, as we come off that, closure. Okay, the next two properties I'm going to write, these were each worth a point, and you tell me what the property is. The commutative property of addition and multiplication. So we come off there. Commutative. I'm going to put it back up so you can see it. There we go again. A plus B equals B plus A. A times B equals B times A. You just reverse, go back and forth like you commute. Okay, coming off there, the next one. Takes me a little longer to write because it has 3 terms in it. But with the multiplication, it's a little bit faster. Okay, there's my property. Associative. There's 2 of them for associative. You may see this in the final. You've seen it in the quiz. You've seen it in the test. You may see it in the final. Okay? If you go into Math 70, you will see it coming off there. So that is the associative property. I'll write that out. Okay, there's the phrase, associative. How many do we have so far? 6, don't we? Okay, let's come off there. You tell me what these 2 are, and this is where some of you lost it. Okay, what property? It's identity. Things don't change. You add 0 to A, you get A. You multiply A times 1, you get A. You retain your identity. No identity theft. Coming off there. The identity. You will learn these, or not do as well in the course. Going ahead, the next one. Let's come off there for a moment. This one, let's see what we can do here. Okay, what is the property? It's the other I property. Inverse. The additive inverse, the inverse of multiplication. Sometimes called the reciprocal. Richie's property. So this is the inverse. Okay, how many do we have now? There are 10. The last one has to be written correctly. And some of you were well-meaning, but you blew it. What is the property?
Distributive.
The distributive property. Because we're distributing the A over this sum as part of a multiplication. So this is sometimes called the distributive property of multiplication with respect to addition. That's best known as distributive. Okay, associatives, come off there. Now, there are 11 I just went through. All I wanted was 10. Now, I just came out of a session with the other tutorial in Math 10. You remember fondly, I hope. Their problem today, memorize 24 equivalents. We spent 20 minutes doing something I hadn't done before to see if it worked better. And then they sat there for about 12 minutes to write 20 from memory of equivalents. Now, if you can remember those 24 equivalents, and that's why you're in here, because you did that successfully, you can remember half that many properties. It's just some letters. Letters are good. Try text messaging these to each other. I had never thought of that before, but that is a way of learning these. Text message these properties every day to every member in the class for 1 week. My guess is you will remember them. Now the problem is I can't ask you to do that on the test, to text message me the 10 properties as your way of, but that might be something I'll entertain. Take out your cell phone and text message me 10 properties. Now the bad point is you might get really frustrated and the thumb action on the keys just go to waste. Overall, I liked what happened in this test. Again, the distribution was great. We had half the grades at A and B. Okay, and there's not a single person in here that could not do better. Everybody had room for growth. Okay? The thing I have been concerned about, and I have been sharing this with Sarah, and about 10 o'clock last night I was finishing up the grading and I took up the paper and she said, see, it worked. I have been concerned about the computerized homework because I wasn't sure it was working as well as I'd like, and she said, see, it worked, because she said it would, and it did, and I think it helped. I was concerned whether you would be able to match the performance, because last semester, as a group, you did an outstanding job. And on this test, as a group, you did an outstanding job. And for every single grade that is less than it should be, I could sit down with you and I can tell you precisely why it isn't as high as you think it should be. And I think you would agree with my assessment. In fact, I could sit down with each of you and you could tell me why it wasn't. It would be exactly what's in my head. I have no doubt about that whatsoever. There isn't a single person in here that couldn't have gotten much stronger on this than they did. I only ended up with 3 A's and I should have had at least 8. And I shouldn't have had a single grade under a C. That's how strong you are as a group. Now, what's getting in the way of that? Life. And I don't mean that in a facetious or sarcastic way. It is everything from car breakdowns to children who are not well, to moves, to jobs, to people making demands that aren't making life better for you. But I don't think in any case, and this is what I was happy about, I don't think in any case it meant that you didn't make an effort. That's important for all of us to understand. You made a very strong effort, but things got in the way. So the question, how do you deal with that? One more point to remind you of. Your quiz grades, plus your homework average, plus this test grade, become your semester grade right at the moment. And your homework averages are strong enough right now on the computer that if I had to, with the quiz grades and that, your grade's going to be stronger than what you have on this test grade. So that's in a positive way. So if you ended up, say, with a mid-range B, and you look at your homework grades and it's at 95, that averages out to an A. If you have 9s on your quizzes, you're sitting there with an A. Now, if your quizzes aren't at high level, where you were given an option to replace one, that would be, if I had to make any one critical comment, when I gave you that option to retake a quiz, you didn't use it to your advantage. You could have replaced a quiz grade with the 10 properties. And had you done that, 1, you'd be sitting there with any of the quiz grades replaced with that one. And that would have helped, and then you would have been prepared for the extra credit problem here, and that would have raised your grade in some cases half a grade, which would have put you in an A. So overall, the assessment, I'm pretty darn happy. You met every expectation as a group I had. I hurt inside badly for those of you who did not do as well as you wanted or as I think you can do. Now, my commitment continues to be to try to find ways of making that happen. What I expect you to do now is go through this test just like we've done in the past. You're going to make corrections, and you're going to show the corrections to Larita, who will then sign off your test, and she will keep a record of that. I expect you to go back and make the corrections. You know what they should be, redo the problems. So, it's been a good week. You did a good job. And let's do better. What do we do next? For those of you who are wanting to know where we go next, it's section 3 in chapter 3. Okay, and it's going to involve adding polynomials, subtracting polynomials. Spend some time doing something I haven't asked you to do yet. That is, read in the text without doing anything in the computer. Spend some time reading so I can cover that on Monday morning. As we close down now, because of the broadcast going out on the 3C Media Solutions, I will be available to answer questions on an individual basis, and maybe some of your grades will go up further. So with that, Chris, welcome to your first solo flight behind the camera with a malfocusing camera and all the things that went. It's, what's Friday, right? Yeah, that must be it. So with that, we did Buddy Holly. What's your choice?